everyone, this is Mankoda studying in Sri Venkateshwara College of Engineering. So here is my presentation on probability, and here are some contents what we are going to talk about today. Introduction. Probability. The probability of events E is given by P of E is equals to M by N, where P of E is probability of an event and M is a number of favorable outcome and N is a total number of events in a sample space. The probability of non-happening events, and it is P of E dash is equals to N minus 1 minus N by M by N, hence P of E dash is equals to E minus 1 minus P of E. Theorem of probability. Addition, theorem of probability, and multiplication or product theorem of probability. Examples of probability. So here, when a card drawn from a pack of 62 cards, find the probability of getting king and king or a queen. Here is the solution. First, the number of possible outcomes n is equals to 52. So number of favorable outcomes m is 4. Probability of getting king is known as p is equals to m by n, where m is 4 and n is 52, so 4 by 52. Next, and number of favorable outcomes m, that is p of king plus p of queen is equals to 4 plus 4 is equals to 8. Therefore p is equals to m by n, that is 8 by 52 is equals to 2 by 13. Next, probability distribution. Here the probability distribution is a random variable x shows how the probability of an event is distributed over different values of random variables. When all values of random variables are on a graph, the values of probability generate the shape, and the probability distribution is by the properties that can be measured. It should be kept in mind that the probability of favorable outcome is always greater than 0, and the sum of all probabilities of all events is equals to 1. Some formulas of probability distribution. Mean, that is mu, is equals to sigma x p of x, and variance v is equals to sigma power x minus mu square p of x. Standard deviation is equals to root of sigma power x minus mu square and p of x. Here, if each value of xi of decreasing the random variable x being the assigned as a real number, that is p of I, such that p of I is greater than equal to 0, and sigma p where it is equals to 1, then the function of p of x is called probability function. Problems on probability distribution. The probability distribution is a random variable x given below that find the value of k and the mean variance of x. Here, as we know that sigma px is equals to 1, that is k plus 2k plus 3k as you see here, plus 4k plus 5k is equals to 1, where k is equals to 151. So those values of k is 151. The main given data is that is mu is equals to sigma xp of x is equals to 3.66. Variance of given data is equals to sigma of mu square minus x square of p of x is equals to 1.6. Then the mean and variance of given data is 3.6 and 1.6 respectively. Types of probability distribution: normal distribution, uniform distribution, binomial distribution, and position distribution, and exponential distribution. Position distribution. Position distribution is a decreasing probability distribution, meaning that it gives the probability of decreasing outcome for Poisson distribution that decreates the outcome of number of times an event occurs and represented by k. You can also use the Poisson distribution to predict and explain of the number event occurred within a given interval of time and space, and that is denoted like as p of x is equals to m power x e power minus m divided by x factorial. Real time example for probability distribution. Probability distribution are used in many sectors. Here is some examples where the concepts of probability distribution are used in real time to describe the population of real-time variable, to test a score in a class or on the standard test, and weight of an adult individual in a population, and blood pressure in a population, and so on, as you see here. Next, random variables. If a real variable x is associated with an outcome of a random experiment, then the x is called a random variable, or a random variable is a real value function whose domain is a sample space of the random experiment. It represents the x is equals to real number, and random variable is are usually denoted by xyz, capital XYZ, and it may be denoted that different random variables are may be associated with the sample space S, capital S, the set of all real numbers, and of random variables x is called range of x. Examples of random variables. Suppose a coin is tossed twice, some of the random variables can be defined as x is equals to number of heads in outcome, y is equals to number of tails outcome, and z is equals to number of two consecutive head. Find the random experiment of all three cases given above. Here is the solution. Outcome of x is equals to hh, and as you see here is the solution. Types of random variables. There are following two types of random variables: discrete random variable and continuous random variable. Discrete random variables in a probability distribution. It is a variable can only take a finite number of values To further understanding this, let us see some examples of random variables where x is equals to sum of the outcomes when 2 dice are rolled. Hence the x is only taken value like 2, 3, 4, 5, 6, so on, 10, 11, 12. Next, and continuous random variables in probability distribution. It is a variable which can take infinite values in a continuous domain. Let us see some examples of derived games. Suppose we have a dart game in which we throw a dart where the dart can be fall anywhere between the -1, 1 on the x-axis. So if we define our random variables as x coordinate of a position, the x can be taken any values from x -1 or +1. There is infinitely many possible values that x can take. That is, x is equals to 0.1, 0.00, so on, and so on. Thank you. Please do like, share, subscribe.
Please share, like, comment, and
subscribe.
subscribe.